The goal of this optional problem is to give you more practice on how to compute the solution to the cost minimization problem, and also to worry about corner solutions. So what I want you to do is to compute the K-mean, L-mean, and the cost function for the case of a production function that looks like this. F of KL is equal to 10K plus 5L, and I want you to do it in general for any Q, for any W, and for any R. Now, hint, when you do this, you have to worry about corner solutions. So let's solve the problem, and it's going to be very useful in this particular case to have a graphical representation of the problem. So this is K, this is L, and notice that here the isoquants, so it's an isoquant, have a slope. I'm going to write here the production function for you, just so we have it in our eyesight. The isoquants here have a slope of -2. In other words, the marginal rate of technological substitution is constant and equal to 2. And what we want to characterize is what is the cost minimizing solution. Now, I hope that it's very intuitive to you that corner solutions are very likely in this case, because suppose that you have that the isocost lines, so I'm going to draw in red the isocost line, look like this. When they are flat like this, you're going to basically want to be at this point. So when they are flat enough, in other words, when R divided by W is small enough, you want to basically use all capital. And we should also be very intuitive that if they are very steep, so if they are like this, you're going to want to be there. Okay? Now, what's the corner case? Well, the corner case is when the slope is the same, in which case you're going to want to be anywhere in there. Okay? So that, if you're seeing that intuition, that basically allows us to write the solution as follows. I'm going to write L mean, comma K mean as an ordered pair as a function of the case that we are in. And the case are going to be if RW has exactly the same slope as the marginal rate of technological substitution, so it's 2, or if RW is steeper, so it's greater than 2, or if it's less than 2. Okay? Now notice, as we said, that when it is steeper than 2, you want to be in that case. So what do we know? We are going to produce only using labor. How much labor do we need to produce Q units? We need Q divided by 5. So that is going to be equal to Q divided by 5, 0. This much labor, no capital. Let's go to the other case. It's exactly the opposite, where in that point, so in this particular case, we want 0 labor, and to produce Q units using only capital, we need Q divided by 10 units of capital, so we get Q divided by 10. Now, for the case in which the relative prices are exactly 2, any point along the isoquant, which also lies in the isocost line, in the cost minimizing isocost line, is a solution. So we can write this as follows: any L, Q that satisfies the following, which is with K greater or equal than 0, less or equal than Q divided by 10. So it's just we're picking an X coordinate, and then given that X coordinate, we have to pick the L coordinate, and L equals Q minus 10K divided by 5. Any point with those characteristics also solves the cost minimization problem in that case. Now, given this, what is the cost function as a function of Q and the prices? Well, let's do it together. Again, there are going to be 3 cases if R divided by W is greater than 2, is equal to 2, or is less than 2. should be very easy to see what the cost function is in the first case. You're only using labor. How much labor? This much. What is the cost per unit of labor? W. So the cost function is W, Q divided by 5. The analogous holds there, and we get that R, Q divided by 10. Now to compute the cost in the intermediate case, notice that all of the points in here lie along the same isocost line. So might as well, for example, calculate the cost using this point. And what is the cost there is R Q over 10 again. Okay? That's the amount of the cost that you will need if you would produce everything only with capital, but it wouldn't change if we change the proportion of capital and labor among those lines. So this is the cost function that we obtain. Notice a piece of intuition about this case, just to check the intuition of the solution. If you're in a case in which the relative prices of capital over labor is very high, then you're only using labor in that case, and therefore the cost function is only responding to W, not to L. The opposite is true when the relative price of capital is very low, then you only use capital, and therefore the cost function only responds to R. So most of the time in this particular case, you're in a corner solution in which only one of the prices affects the cost function.